always refer to the APR control as a continuous capacity modulation device, and it's capable of matching your system capacity to that ever-changing load conditions of the space. Specifically, the APR control can be added to the DX equipment, ranging from split systems, package units, and even chillers. It can be installed on new systems, retrofit applications, and available from the factory from some of the
Hold on just a second.
Yep.
I have a question about chillers.
Yeah, go ahead.
Is this capacity control for chillers too?
Yes, capacity control for chillers as well. Yeah, so you can put them on, whatever circuit or stage of cooling.
Hang on, Robert. Robert, you're fading away. Did you back away from your mic?
No, I'm still there. Can you hear me?
Yeah, it sounded like you faded away. Okay, go ahead.
Yeah, so you can install them on chillers. We've definitely had success installing them on chiller applications. Specifically if it is, oversized unit, or if they have very low load in the space. We found, some instances where maybe the lead compressor is the only compressor that's on, and it's just constantly short cycling, causing issues in the space and, burning out compressors. So we definitely found some success installing chillers as well.
Can I spend a little time on this if you don't mind?
What do you got going on?
Okay, well, I'm going to ask you the quick question. It'll be a quick answer. If I have a 30-ton compressor, how far down can your control take me down to capacity-wise?
So for a 30-ton compressor,
this is a scroll. I'm sorry. This is a scroll compressor.
Right. So for like a 30-ton scroll compressor. Depending if it's a split system or a package system.
No, it's a package system. It's water cooled.
It's water cooled. Yeah. So on those, our largest APR control is an APR 41010. So that's a 10-ton capacity control. So that can get you down from 30 tons down to about 20 tons on that compressor.
What if I put two of them on there?
Yeah, we have seen sometimes where you can, put them together. That's something, if you were trying to do that, I'd have you speak with our senior technical engineer, Jason Santos. It's a little bit of a different.
Oh, okay, so it's a possibility.
It is a possibility.
Okay.
Yeah, there are some times where we've twinned them together.
Okay.
Where you can actually get some more capacity as well.
Okay, I'll stop. We'll stop there. I just want to have that as an avenue to talk about in the future because I have a job where this could possibly be used. Okay, so let's go back to the training part. Thank you for allowing me to interrupt you.
Oh yeah, no problem. Any questions, just let me know. You're the only one on here today, so.
Okay.
We'll go to the next slide here. So yeah, the APR control is available for multiple refrigerants. R410A and R22 obviously are the most common, but we do work with other refrigerants such as 134A, 407C. We have the ability to utilize with other refrigerants that aren't listed. If you have any specialty applications that need the modulation, just give us a call and we might be able to figure something out for you guys.
Okay.
The R410A controls are factory set at 118 psi, which is equivalent to about a 40-degree evaporator coil temperature.
Okay.
They are field adjustable from 95 all the way up to 130 psi. The R22 controls are factory set at 60 psi, which is equivalent to about a 34-degree evaporator coil temperature, and those ones can be adjusted all the way up to about 80 psi, depending on your application. Please be sure that if you adjust the APR, you want to keep that evaporator coil temperature below the dew point of the entering air, so you're always dehumidifying.
Okay.
And here's a picture of the APR control. So regardless of the tonnage of the system or the refrigerant being used, the APR control is always going to be made up of the same three major components. First off is going to be the compression ratio reduction valve. The second is the desuperheating chamber. And the third is a liquid injection valve. And we will go over how these work over here in the next slide. And right here we get a representation of the traditional refrigeration circuit with an APR control installed. So during those part load conditions, there's going to be a point at which you're providing more cooling than necessary. This means that the heat content in the return air across the evaporator coil is decreased, causing a drop in your suction pressure. For R410A, that set point for the APR control's compression ratio reduction valve is around that 40 degrees Fahrenheit or 118 psi, again adjustable if needed, which we will go over. Once your suction pressure starts to fall below that set point, that compression ratio reduction valve will begin to open up and begin to modulate. The valve is going to divert that discharge gas from your discharge line into the desuperheating chamber. Inside that desuperheating chamber, it's going to swirl around to dissipate the heat and will eventually return back to the suction line as a cool gas. If that load continues to drop and the APR control is in full modulation, meaning it's diverting as much refrigerant as possible, there's going to be a point where that desuperheating chamber just can't dissipate that heat fast enough. And that's where that liquid injection valve is going to come into play. So once that senses the compressor's superheat reaches above 20 degrees Fahrenheit, the liquid injection valve is going to start to inject a little bit of liquid into that desuperheating chamber with the gas. It's going to cool down that discharge gas even further and send a cool enough gas back to your compressor. It's important to note that at no time will there be liquid exiting that desuperheating chamber. So this action is going to unload your compressor. An unloaded compressor reduces that effective tonnage of the evaporator, decreases the amp draw of the compressor, increases your suction pressure, and also reduces head pressure. For this reason, the APR control could be considered a modulating external unloader.
Wow, that's significant. Like I said, I got this chiller job that when they go to full when they've fully used up the one of the stages, which is 30 tons, then they need to bring it down, another 4 degrees, right? Or 5 degrees because of temperature control. It bangs on another 30 tons, like right now, right? And it's just that then it's a race game. It's a game between it's a race between whether the set point gets met or the freeze protection goes off. And
exactly.
It's insane that this guy did not spec digital what do you call it? Digital scroll. It just kind of it just kind of silly, and it's in a restaurant, and restaurants loads change constantly, so
yeah, they're perfect for applications where you would use a digital scroll and pretty much give you that similar turn down rate on most applications.
Damn.
Also, it's going to give you, like I said, a compressor protection, frost protection, and they're a lot quieter than the digital scroll. So if noise is an issue, then APR control might be a good solution for you as well.
To overcome the digital scroll functionality
And the noise. I've been on a roof where
you're right.
School, and you got all these rooftops that are on this little roof, and they have classrooms there, and you got these digital scrolls that are all banging off and on and making noises all day long.
You're right. Yep. That's a good point.
It's going to help out with the sound on that.
That's a great point. Okay.
Yep. And we'll continue on here. And,
sure.
So we manufacture a variety of APR controls, like I said, for a variety of system sizes and refrigerants. For today's purpose, we're going to focus on the APR control for our R410A systems. Keep in mind, we do need to take in a multitude of system parameters in consideration when sizing the APR control for your system. So we are definitely a little bit annoying when we're asking the questions, but it is for a reason.
Okay.
Prior to installing, please confirm with us that the APR control is properly sized for the system. To start, we would need the tonnage, refrigerant type, and whether it's a package or split system. Here at Rawal Devices, we take pride in sizing the APR control conservatively. We always want to make sure proper oil entrainment for your compressor. Package systems allow for more flexibility in terms of modulation due to the unit being self-contained and having those shorter pipe runs. On the other hand, like I mentioned before, for a split system, that suction line size, the outside diameter specifically, is the most important parameter which dictates how low the system can safely modulate. So each specific suction line size is a minimum velocity and associated tonnage required to ensure proper oil entrainment at all times. Finally, it's important to note that we do size off the lead circuit or that lead stage of cooling. This could be the first compressor on or even the first stage of a two-stage compressor.
Okay.
For example, if you get a 5-ton unit with only a 1.5-ton load in the space, the APR 410-3 would divert that excess 3.5 tons of capacity back into your suction line, and it's only going to send that necessary 1.5 tons of capacity throughout the rest of your unit. So as long as there is at least a 1.5 tons of load in the space, that APR control is going to extend that compressor runtime of the unit, and it's going to allow for that continuous dehumidification while also preventing freezing and liquid flood back to your compressor.
Okay. Hang on, real quick. Can you go back a slide? If I have a 6-ton, I got a 10-ton unit, got a 6-ton compressor and a 4-ton compressor. On the 6-ton compressor, first stage, which product would I, just in general, which one would I pick? The 5.5-ton, the 6.5-ton device, or the 3.5?
So if it's like a dual circuit and your lead stage is a 6-ton, you're gonna go with that. You're again gonna go with the 410-3.
Okay.
That's pretty much as you're gonna get. The APR 410-5 is a little bit of a one-off valve. That pressure set point is a little bit different than the others. That one's set at 109. So we use that one for specialty applications, kind of like VAV, or if you're using like outside air, anything where that, or VFDs on the indoor fans, anything where that suction pressure is going to be getting lower, kind of down to that 109 PSI mark. We'll use that 410-5.
Okay, that's fine. I just ordered one. I just want to now that I've had this class, this demonstration, I've got to go back and make sure I got the 410. I got the 410-3.
Like we said, we size it off of that lead stage of the small, lead stage of cooling. If you do have two compressors, on that same circuit, we do it off of the, like I said, the lead.
The lead circuit. Okay.
If it's a dual circuit, lead circuit.
Okay.
All right, so here's a picture of the APR control installed. It's important to know the APR control is position sensitive. It's meant to be installed vertically. It's not designed to be installed on its side, at an angle, or on its back, or anything like that. You want to make sure that access Schrader port on the desuperheating chamber is always facing downwards. You also want to make sure the APR control is securely mounted inside the unit.
Okay.
The reason we have to be mounted is because the weight of the APR control, as well as a vibration from the unit, can cause potential cracks if left suspended by the pipes over time. Kind of like with any other components of the system.
I see.
So if the cracks are caused on the connections, if it wasn't mounted, the warranty will be voided. So just make sure that you mount that thing. It's also important that you include isolation valves. Here you can see two of them. One is on the compression ratio reduction valve. The other one is on our liquid injection valve. The one that's not shown is on the mixed gas discharge line. It's actually behind that little bracket, or that's what they said. It's there.
Yeah, I see. Yeah, I was gonna put ISO valves on it anyway.
Yeah, definitely. It's definitely a good idea to put on there for startup and for troubleshooting purposes. They don't come with the APR control. You just get that at any local supply house.
Okay, I just checked my file. I got an APR 410 2R, 2 Romeo.
Yeah, 2R is going to be good too. Yeah, so the 2R is going to be a 3-ton valve, so that would be for that application as well. We were using the modulators. We didn't really have the 410-3s available for a period of time. Those pretty much just came back in.
Okay, so can you
pretty negligible difference between the operations.
Okay. All right, sounds good.
Yeah. And here you can see two other acceptable installations for the APR control. On the left, you can see there's a
that's cool.
Behind the APR.
That's pretty cool.
That thing that's a really good install. A little bit overkill, but honestly, I like that better than some of the other ones we've seen. It has little clamps on there.
Yeah.
Some kind of has a rubber on that help out with the vibration. Excellent install. On the right, you can see it's just a little cush clamp on a piece of unistrut that's kind of right next to your condenser coil there.
And that's acceptable. That's acceptable?
Either one is acceptable, yeah.
And by the way...
I've even seen where they Yeah, go ahead.
By the way, the ports. What's more important for us? Is it better to have the access ports as depicted on the right-hand side? Well, wait a minute. The one on the right has the port on the system side. The one on the left has the port on your device side. Which is the better to have? Have the access ports on your device side?
I mean, I would think it would be better on the device side.
Okay,
since you probably already have access
on the other side. On the other side. Okay.
Yeah.
That's good. That's good.
Like I said, you do have that access Schrader port on the bottom of the desuperheating chamber. The purpose of that's not really for like checking pressures or anything like that. That's more for if you needed to like isolate the APR control, if you ever need to replace
I got
it
you.
for some reason.
Okay.
You can isolate all around it. You can recover off that little Schrader. You could just cut it out, unbraze it, and put a new one in.
Sounds good. Sounds good. Okay. So the one on the left is probably a more for future. I'm just thinking of future stuff. So, okay.
Yeah, for sure. And here's an image to show that adjustment screw on the compression ratio reduction valve.
Yep, there it is.
You're first going to remove the cover bolt on the adjustment stem to access that Allen set screw.
Yes, sir.
The Allen set screw in the stem will change the pressure at which the APR control is set to begin opening. So a standard 5/32 Allen wrench can be used to turn the screw and adjust that pressure setting. Make a note, your adjustment screw may be on the bottom of the compression ratio reduction valve. I believe on the valve that you have, it is on the bottom of that. So that's going to be a little bit of a different setup, but very similar of adjustments on that. Again, we do offer many types of the APR controls, and they can have the different set point style adjustment screws. If you have any questions or doubt, just give us a call.
Okay.
Okay, this is very important. Never adjust the liquid injection valve. That liquid injection valve is preset from our factory. Adjusting that liquid injection valve will void the warranty of the valve.
Where is it? Where is it?
The liquid injection valve is the other valve, not the one that has the adjustment screw on there.
Okay. Okay.
It's going to be the one that has the blue liquid line sticker on there. It's the one you're going to tee into your liquid line. Just don't adjust that one like we talked about before. That's just meant to basically protect your compressor from overheating. It's just maintaining
Gotcha.
that 20-degree superheater or 65-degree suction line temperature. That's all that really is doing. But it's really hard to get back into adjustment if it gets moved out.
I'm sure you have a sticker on there, right?
We got a sticker on there.
Very good. Thank you.
Yep.
Does it use the word never?
Yeah, never adjust that.
Okay.
If you have any questions, just give us a call.
Got it. Okay, sir. Thank you.
Yep. And this is the image that's going to be coming in the box. You probably have it with you now. Each APR control is going to have either 3 or 4 connections. Most do have 4 connections. The first is going to be your compression ratio reduction valve. That's going to have that red discharge line sticker on there. And that compression ratio reduction valve is teed into the discharge line between your compressor and the inlet of your condenser. The next connection is on your liquid injection valve, and that's going to be teed into your liquid line between your condenser and before the TXV. You also want to make sure if you have a filter dryer, which I hope you do, you want to make sure that liquid line is teed in after the filter dryer, if at all possible. The third connection is our mixed gas line, or some people call it the mixed gas discharge line. And that comes out of the top of that desuperheating chamber. And that's going to tee into your suction line between the outlet of your evaporator and the inlet of your compressor. That fourth connection that I talked about, which a majority of the APR controls have, which yours will, is that 1/4-inch external equalizer line.
Right.
And that's going to tee in, and that's going to tee, as you can see in the picture there, in between that tee on your suction line and the inlet of your compressor, okay? Most APR controls are going to have 2 sensing bulbs as well. Those sensing bulbs are going to be installed and strapped to the suction line after that mixed gas line tee in the inlet of your compressor. Also, as you can see, those manual shutoff valves in the picture labeled G for your gas, L for your liquid, M for your mixed gas line, and there's that 4th which is optional as there's no flow going through there. That's just sense and pressure. That's your EE, external equalizer line. But if you don't want to fully isolate the APR control, you need to put that fourth one in there.
Okay, real quick. Where do you want the filter dryer? Just traditionally before the expansion valve?
Yeah, so I mean, you obviously want the filter dryer before the TXV. I'm just saying, if you can fit in, you know what I mean, the liquid line dryer before that T, it's good just to kind of filter out any crap before it goes into the APR control. I have seen some instances where people have installed like a smaller, you know, smaller filter dryer on the line that's actually going into the APR. It's a little bit overkill, not 100% necessary. It's just kind of good common practice,
Okay.
just to filter out any crap before it goes in.
Yeah, just so I got this straight. Do you have a mouse on this thing? Can you swing your mouse on this picture?
Let me see here. I don't know if I
You
can.
see my mouse?
Hold on one sec. Let me see. Can you see that?
Yeah, I see it. So where do you want your traditional dryer is? Where would the traditional dryer is going to be before the?
The traditional dryer is going to be on your liquid line.
That's right.
It's going to be somewhere between here and here. So like if you're so say if your dryer was right here,
Yeah.
maybe try to put that T like right after the dryer.
Oh, I see. All I got to do is move this liquid injection down, okay, and then put my dryer, move the T down, and then put my dryer to the left of the T. Got it. I'm done. We're good. Okay.
Exactly. Yeah. Put the dryer and then put the T.
Understood. Got it, sir. Okay.
All right. Perfect. All right. Let's move on here. So yeah, this is for the heat pump installation. This is going to be similar. Just some slight differences.
I don't in this application. I don't have heat pump.
Yeah, this is for a heat pump. Did you want to go over this one?
No, I don't need to.
All right, we'll go over that one here. Yeah, skip there. And this is for a tandem compressor application.
I don't have that either.
Yeah, so if you ever get one though, basically if you got two compressors on one circuit, you want to install the APR on the common discharge and suction lines that
Sure.
you can see there. And that's just so either one of those compressors can modulate while they're on.
I will say this: if we do this again on a different application, we will go through this training again.
Oh, perfect.
Yeah, I'll do this again, and it'll be a different application. We'll absolutely do it again.
All right, sweet. We also get product overview trainings as well if you want to go further in depth, or if you got like a sales team you want to involve or anything like that.
Sounds good.
All right, and this is a better picture of the sensing bulbs. We recommend those sensing bulbs be installed at the same point on the pipe, roughly at 10 and 2 o'clock.
Got it?
You want to make sure they are fully insulated, making good contact with that pipe.
Absolutely.
We want to be fully insulated. Yeah, we want to make sure they're fully insulated so they're not sensing any ambient temperature, as that can affect the functionality of the APR control.
Sweet.
And very important slide here, just go over to brazing the valve into place. Be sure to follow your proper brazing techniques. They are critical for a proper installation. Make sure you use a wet rag on the valves when you braze it in. So just make sure you use a wet rag. We don't recommend using that heat paste. We have seen that heat paste bake the valves in the past. So
really? That's good to know.
Like we say here, the rags are cheap and the water's free. So go ahead and wrap those up with some wet rags and don't overheat those puppies.
Yeah, water's free. Water's free in this country.
Exactly. So yeah, overheating the valves will void the warranty. So just make sure you don't bake those things.
Okay. Question: do you all have ProPress? Can I ProPress all this?
We do not have ProPress fittings, but I mean, if you wanted to braze in your stubs and you want to ProPress everything else, that's totally up to you.
Not a problem. Okay, thank you.
And also, a light sanding is all you're going to need on the valve connections. They are a copper-coated stainless steel, and over-sanding can result in a failed joint.
No, we probably won't sand it. It's not necessary.
All right, perfect.
I mean, unless you telling me something I don't already know. I mean, doing this 30 years, but I'm always willing to learn. Are you saying light sanding kind of roughs it up a little bit so the solder will flow better? The Silfoss?
Yeah, it's just gotta kind of rough up that coating a little bit.
Okay.
And it'll just flow a little bit better. So
Got it.
You know what I mean? If you want to, do your best, like I said, best pipe practices. If you found whatever works for you best in the past is going to work,
Okay.
that's fine. We do recommending a couple quick scuffs. Nothing crazy.
Sweet.
And again, just make sure you follow your best piping practices. We just want to make sure it's a clean install and nothing is going to be rubbing against anything else.
Sure.
We have a lot of calls about those
Sweeping.
capillary tubes on the sensing bulbs leaking because they're swinging in the air and
Sure.
rubbing against something. So just make sure nothing is going to be rubbing.
Yeah, long radius elbows, things like that.
Exactly. And it is key to note that Rawal Devices only sells the APR control right there. We do not supply those additional materials here on the slide.
Not a problem.
This list of materials, so this list is not inclusive. Each job is obviously different than the next. So the installing technician is obviously going to have to make the judgment of what materials they need for the job there. As you can see, you'll need your T's, your isolation valves, some miscellaneous copper 90 fittings, pipe clamps, some insulation for your sensing bulbs, obviously wet rags, protect the APR control when brazing.
Where's the torch?
Probably gonna want to
Where's the torch on the picture?
We need the torch. We need everything like that as well. Yeah, exactly.
Okay. I mean, you got everything but the torch, dude, and the little man in the corner.
You get everything there. Yeah, I know. You need me there with a torch in the corner. Yeah, exactly. So obviously, if you're over up the system, it's always a good idea to put in that new liquid line dryer. Use the right solder. Here at Rawal Devices, we recommend just using that Stay Still 15% braze rod for our 410A.
Yes, sir.
If it is an R22 application, you can just use that Stay Bright number 8. It's fine.
Sweet.
And this is just pretty quick. So some tips in insulation. Go ahead. You're going to probably have to reclaim the refrigerant out of the system. Mount that APR control with an access Schrader port facing downwards. Go ahead and install your T's. The most important T is the one on your suction line. If you're installing that one on a horizontal portion of your suction line, you just want to make sure that the that top of the T is kind of facing either upwards at an angle. You don't want it facing sideward, like sideways or downwards. You just don't want it to cause any sort of oil trap if the APR control is in full modulation. All right.
Okay.
So go ahead, install all your manual shut-off valves, braze everything in. Obviously, use the best piping practices, brazing techniques, all that good stuff we talked about. Go ahead and pressure check your system with nitrogen. With those valves open, after you've checked and you got no leaks, go ahead and evacuate your system.
Sure.
Try to achieve whatever microns you're trying to get down to. Hopefully 500 or below is recommended. At that point, once you're down to your micron level that you're trying to get to, go ahead and shut off those isolation valves to the APR control. Shut off your vacuum pump, do whatever you're going to do. Then you're going to go ahead and charge the system as you would normally. Charge it back to whatever the manufacturer is recommending to that charge be, okay?
Okay.
At that point, you're going to go ahead and start the system up. You want to make sure that it's running efficiently, running properly, make sure all your pressure, superheat, subcool is looking good. And then at that point, you want to go ahead and open up the isolation valves to the APR control.
Okay.
And again, this is just going over some additional points. We do not need any additional refrigerant. No more, no less refrigerant. Again, just whatever the manufacturer is recommending for that system. Very important again, do not adjust that liquid injection valve that is preset of the factory to maintain that suction line temperature of 65 degrees Fahrenheit. Call us here at Rawal Devices if you have any questions. That warranty may be voided if you adjust that. And though the APR control is a great way to prevent liquid slugging or flow back to your compressor, it is designed to be an operating control only and is not a safety device. Any fail-safe switch you have in your system or control is a great idea on any system with or without the APR control. So high pressure, low pressure, anything like that, make sure you have that in there. It's not a safety switch.
Okay, gotcha.
And that's pretty much it. I will leave that slide up here. That is our 800 number,
Okay.
800-727 6447. Again, if you have any questions or concerns, just feel free to give us a call. Either myself or one of the other teammates here will answer any of the questions that you might have.
Okay, I do have you have a couple more minutes?
Yeah, sure.
Okay, here's my question, okay?
Yep.
We bought this, we sold this to the customer. We got a lot of good feedback about this thing and that these things actually work. However,
Yep.
one of the things that I'm used to, and I just wanted to cover this real quick, is we're used to the traditional put it into dehumidification mode, right? There's a humidistat calling, tell the reheat coil to start, that kind of stuff, right?
Right.
Do you have a psych chart that you can send me that shows psychometrically? Because all I see this thing is doing is just raising the evaporator, just like injecting just a hot gas bypass, and not dehumidifying. I mean, I don't see how this thing works. I mean, I know mechanically how it's supposed to work, but I can't see in my mind's eye. Here's what I used to do. We had a job, real quick. The musical instruments were not working properly. They were in a very moist environment. They had an air conditioning unit and they had electric duct heater. I put a humidistat in. The humidistat called for cooling, and then I put a discharge air temperature sensor to control the duct heat. And I let it run at full capacity on the compressor, and then I reheated the air, okay, to a discharge temperature of like 70 degrees, okay? And that's what I'm used to. But I don't see how just raising the evaporator temperature is. I just don't see it in my head.
It's pretty crazy. When I started here, I started here about 7 months ago. I was in the field for almost 20 years before I started here. And when they showed me everything, literally part of my French the first week, I was like, this thing's fucking magic. It is crazy, the issues that I can solve. But it's basically just extending that compressor runtime.
Okay.
You know what I mean? If you're in those low load conditions and you're short cycling a compressor, if it's only turning, run for 5-10 minutes, you're not pulling any humidity out of the air. So by extending that compressor runtime, you're leaving that coil active for a lot longer, and you're reducing that capacity. So like most of the days, you know what I mean, that system is already oversized. It's basically it's only sized for
the cooling load.
The hottest few days of the year.
Correct.
So the rest of the year is significantly oversized. So I mean, your temperature is already going to be lower than you're going to need. So it's basically just reducing that amount of liquid refrigerant that's going to that coil. So instead of like a hot gas bypass, where you would actually load up that coil with discharge gas, you're taking that discharge gas, like we talked about, cooling it down and sending that cool gas back to your suction line to your compressor.
Right.
So that's where you're going to get that dehumidification out of the coil. Like I said, you just want to make sure you keep that coil temperature below the dew point of the incoming air. Like we talked about, that compression ratio reduction valve is adjustable. We preset that at 118 psi for the 40 degree evaporative coil temperature. As we found, that's a pretty good set point for most applications.
Okay.
They used to be set at a lower set point, but we were getting some calls for the first few years on the 410A valves, and most of the time it was solved by just turning that compression ratio reduction valve and raising up that pressure a little bit.
I see.
So at that point we decided to leave the pressure and that temperature setting there. So kind of depending on the application, you may need to adjust that. And for a lot of applications, I mean, the APR control is going to solve the issue just by extending that compressor runtime. There are some scenarios where the APR control is going to be part of the solution. It has been used with, reheat and other modulating, reheat as well. So the kind of depending on what you're going to be using it for, but we have installed them on thousands of systems, rooftops, split systems, and like we said, chillers before, and have great success. So, like I said, I was shocked when I first started here. I'd seen them in the field. I hadn't worked on them, a ton, but I'd had kind of seen them here and there. And when I started working here, I was just shocked by really how well they work.
Sure. Okay. All right. I think we talked about. I think I've already talked to you about this now that you mentioned it, because you did mention the 7 months after you were here and you saw this thing was wonderful. Can we go? Can we go back to this chiller real quick?
Yep.
If you got time.
Yep.
So basically, okay. Another. You've answered my question. I've got this plate frame heat exchanger on the condenser side. I don't know what's on the chiller side. It's plate frame. They're both plate frames. So it's just a matter of basically. I mean, this might just be the solution for this chiller job, because I don't see how they're going to manipulate this thing in such a way by just mere set point. I just don't see it. We need capacity control for the compressor. And what I'm hearing you say is that we're actually limiting the capacity of what the compressor can do in terms of...
Yeah, I mean, the capacity, the compressor is just basically going to be running, you know what I mean? It's just averting that, so it's just going to keep that same compression ratio. That's why we call that compression ratio reduction valve. That compression stroke is just going to stay the same the whole time. You know what I mean? It's not going up and down. It just going to keep that at a constant. And like I said before, we've used these in chillers. I specifically sized one up for one out in California. They had a giant building with a multi-stack chiller system, multi compressors on there, and it was basically just for some sort of a process. They had like one classroom, one teacher that needed that process in the whole building. So they literally had one compressor that was short cycling just to keep that, and it really was obviously not doing a great job, and it was going to fail if we didn't put the APR in. So we put the APR in there, and it's working like a charm, just keeping that thing just humming away and keep that compressor running at that same ratio, and just maintaining, matching the load across the evaporator, you know what I mean? So like I said, as your load decreases, you're basically just load matching across your evaporator, that capacity from your compressor. So it's pretty nifty for sure.
Okay. All right. I'm going to present that to this engineer and say, hey, listen, this looks like a good alternative, because I don't see... they're not going to put in digital scrolls. I mean, we're talking a lot of money to convert this over. And your product, even if you're, I mean, digital scroll 30 tons is going to cost somebody what, 10 grand, maybe 15 grand, and then they got to do programming, and they got a lot of other things they got to do. The only real question is how much piping space I have, So if we would have to get you guys involved to be able to solve this problem, because I don't see how banging on 30 tons. To overcome a 5-ton load, an additional 5-ton load that comes online is going to solve the, it's just not going to, it's not going to work, and it's proved that it's not working. Turning on 30 tons just for an additional 5-ton load. So, okay, that I'm glad we talked. So we'll be in touch.
Yeah, definitely. And when you're ready to go over that chiller application, just reach out. I'll probably set you up with Jason Santos again. He's a senior technical engineer. He kind of goes over a little bit more of those chiller applications. But like I said, we've found great success with those applications. So just let us know when you're ready to size that up, and we'll be ready to help out.
All right, sounds good. Well, thank you, and we'll be in touch. And I appreciate the training.
Awesome, Russ. Have a great day. Be safe out there.
Okay, you too. Bye-bye.